So if we're doing sinusoidal modeling, remember sinusoidal equations are sine or cosine equations with transformations. So basically we're using these to model real world phenomena. And we've been doing word problems here and there throughout the past few lessons. This is just a focus lesson on that. So our first question says the tides in a particular bay can be modeled with an equation y equals a cosine bt plus d. High tide is at 12 a.m. on a particular day. Let T represent the number of hours after 12 a.m. and H of T, so this should really say H of T here, represent the depth of water in the bay. The maximum depth is 36, the minimum depth is 22, and high tide is hit every 12 hours. So we have a lot of good information. First, tides are periodic, so we would use a sine or cosine equation to model them. And we're going to try to graph this out. Now, sometimes I think it's easier to write the equation first. Sometimes I think it's easier to graph first. We're going to go in the order that it says. So we're starting at high tide. So that means when T is 0, we're going to start at the high tide. My high tide is 36. So maybe I make my graph go up to 40. And this has nothing to do with quarter points. It just happens to go up to 40. So I'm going to label the scale that way. We just do quarter points max when we graph these. So looking at the next part, we want a depth of 36. And we're going to go down to the minimum. This information is my period that it repeats, gets back to high tide every 12 hours. So I'm going to put a 12 over here. I just have to graph one full period, so that works. And there's my quarter points. Pretty easily labeled, so I am going to do that. So looking at the next point for 12, right there. Right, so we're back to high tide. And in the middle, I would be at the bottom at low tide. So this is just a cosine equation. And, low tide is 22. So I do not want to go that low. So low tide is 22, so we're right here about, and I don't have a scalar, I don't have a grid, so as close as I can is fine. Now, in between those two is the number 29, so I just average those two. So at my quarter points, I want to be around 29. So here is my cosine graph, as I said. Not the best one I've ever drawn because I have to do my scales myself, no grid lines, but pretty close. So now we're going to write an equation for this. So first off, going through those qualities, we know it's positive cosine because we're starting at the maximum. My midline is 29. We already found that. So my amplitude, max minus midline, is 7. And my period, we know, is 12. So my B value is going to be 2 pi divided by the period, 2 pi divided by 12 for pi over 6. So I have all my qualities now, and I can plug it into my equation. So I have 7. It tells me to use cosine, which matches up best with what I have. Pi over 6, we want t plus 29. They told me to use h of t, so I'm going to use h of t instead of just y. So from here, we might have a follow-up question that has something to do with the graph. So this one says, tanker boats cannot be in the bay when the depth of the water is less than or equal to 25 feet. Using the domain 0 to 12, so that's what we have on our graph, graphically determine the time interval when the tanker boats cannot be in the bay. So basically, if the water's too shallow, they can't be in the bay. So graphically, what I would do, and we're going to write this out, I would graph my function, h of t is y1. And basically here, we want to see when they're below 25. So we would graph a y2 equals 25, and we'll do that in the calculator now. So 7 cosine pi over 6t plus 29 My window, I'm going to set it up so I'm going 0 to 12 by 3s. And I went 0 to 40, and optionally I can also put in that I went by 10s, just making everything kind of look nice. And there's my graph, and I see my graph does look like what I want it to look like. I'm also grasping 25. So there is a picture of what I have. So I need to find these two intersection points. So second calc intersect. And I'm going to use the enter, and I'm going to guess this point is around 3. So I'm going to type in that 3 like we talked about we could do. So my first intersection point is 4.16, comma 25. Looking for rounding, I need to round to the nearest tenth. So I have 4.2, comma 25. Second intersection point, going through the same process. So second calc intersect, enter, and I'm going to guess this one's around maybe 8. So I have 7.8, 25. So from 4.2 to 7.8 hours after 12 a.m., right? That's when they can't be in the night. So suppose that high tide was at 1 a.m. instead of 12 a.m. So what the problem is, we set up this equation super nice because we can just start right at the maximum. But what happens if I actually wanted to graph this equation? So I wanted to start at 1 a.m. and everything was slightly over. So if I look at that, if I wanted to move my graph to become the black graph is the one I now want. I want it to be at 1 a.m. That's a shift right 1. So basically, I would take my cosine graph, keep it exactly the same, and if I want to go right 1, I'm going to do a t minus 1 plus 29. And just to check and see if that works, I'll use my insert button here, second insert, and I'm going to have to do another second insert again. So I'm just going to look and see what this graph looks like. And if I look now, you can see, right, my maximum got shifted over a little bit, so that does shift the graph so that high tide was at 1 a.m. This is definitely advanced to do those shifts, but it is something that's possible. So the next one, a little less work because we already have an equation and we're just answering things about it. So it says the height of a yo-yo above the ground can be well modeled using the equation h equals 1.75 cosine of pi t plus 2.25, where h represents the height of the yo-yo in feet above the ground and t represents the time in seconds since the yo-yo was first dropped from its maximum height. So if you think about a yo-yo going up and down, kind of, periodic, definitely, it can be modeled by a sinusoidal equation. So first question says, what's the maximum and minimum height? So we've done a lot with maximum and minimums, and we know we're starting from the midline, and we go up by the amplitude, and midline down the amplitude. So if I calculate these numbers, the max is 4 feet, and the min is 0.5 feet. So those, I showed the calculations that led to my answer, so those are the maximum. How much time does it take for the yo-yo to return to the max height? So this is a period question in disguise. So we know for period, we do 2 pi divided by pi. So we got that is 2, time unit is seconds, so it's going to take 2 seconds.